Lesson 1. The verb to be. Hello and welcome. My name is Martin Twells. I'm a teacher. I teach English, and this is our first lesson. I'm a teacher. I'm from London. This is my wife. She's a doctor. You are, your students of English. I'm from London. She's a doctor. Your students of English.
Choose the correct option.
There aren't any books on this shelf.
Karen's eyes are blue.
This medicine isn't for babies.
Are you sure this is correct?
Fiona is absent today.
People in the south of Europe are very happy.
This film is boring. Let's go home.
I'm a doctor.
Friction slows down moving objects because it acts in the opposite direction to the object's movement. Friction is produced when two surfaces rub against each other, including when objects move through air or water.
Friction caused by contact between two surfaces, the tyre and the road, resists forward movement. Grip, produced by friction in the gears, allows the bike to move forwards.
Let us observe an example of air resistance. Air resistance, or drag, increases as speed increases until the forces are equal or balanced so that the object, in this case the aeroplane, moves at a constant speed.
The force of gravity, or weight, will cause a person to fall to earth very quickly, overcoming the drag of their body. Without a parachute, a falling person can reach a speed of 200 kilometers per hour. Drag can be greatly increased by using a parachute, which has a large surface area . A cyclist, for example, pushes the pedals to provide a force to move the bike forward. As the cyclist accelerates by pushing on the pedals of the bike, the air resistance increases. Friction from the chain, gears and axles also increases until all these forces equal the forces pushing the bike forward. At this point, the cyclist travels at a steady speed because the forces are balanced. The hydrogen atom is the simplest existing atom. It is made up of a nucleus consisting of one proton and one electron. Thus, the atomic number of this element is 1. Note that the hydrogen nucleus is exceptional as it does not contain any neutrons. The helium nucleus consists of 2 protons and 2 neutrons. The atomic number of this element is 2. The helium atom has to be electrically neutral, so there are 2 electrons travelling around the nucleus. Subsequently, the atomic number of lithium is 3, beryllium 4, etc. The atomic number, that is, the number of protons in the nucleus, identifies a given chemical element. For example, only carbon nuclei contain 6 protons, whereas nuclei of other elements are characterized by different numbers of protons. Thus, each chemical element has a different atomic number. The atomic number of an element can be found in the periodic table, written in subscript before the symbol of the element. All the elements in the periodic table are arranged in order of increasing atomic number.
When the door is opened slightly, it makes an acute angle. An acute angle is an angle less than 90 degrees. The door has a few right angles. A right angle is an angle exactly equal to 90 degrees.
Choose the full angles. Now choose the straight angles. Choose the obtuse angles. And now choose the reflex angles. Choose the acute angles.
Look at the streets in the city. A cook has cut a pizza into 5 pieces. We will prove that the sum of the interior angles in any triangle is equal to 180 degrees. We draw a parallel line and mark the new angles theta and phi. Note that the angles alpha and theta are alternate angles. The angles phi and beta are alternate angles too.
We tear out the angles of the triangle. Then we arrange them side by side so that the arms of the triangle create a straight line. It is a straight angle. Thus, the angle obtained is 180 degrees.
We move the match along one side of the triangle. We rotate it by the angle gamma. Now, we move the match along the other side of the triangle. We rotate it by the angle beta. And then we do the same until the match reaches its initial position. The match rotated by an angle of 180 degrees, so the sum of the interior angles of a triangle is 180 degrees.
We place a drop of the following liquids on litmus paper and universal indicator paper strips using a glass rod. Distilled water, vinegar, citric acid solution, dilute sulfuric acid, and an aqueous solution of table salt. Universal paper and litmus paper turn red on contact with acids. Let's test the electrical conductivity of various solutions. A different solution is added to each of 6 beakers. Nitric 5 acid, dilute solutions of hydrochloric acid, sulfuric 6 acid, and phosphoric 5 acid, a sugar solution, and distilled water. In each beaker, electrodes are placed for testing the conductivity of the prepared solutions. The lighting up of the diode indicates that the liquid conducts an electric current. The sugar solution and the distilled water do not conduct electricity, which is indicated by the unlit diode.